Let's have a look at a few more vertical and horizontal transformations. Let's find the transformations of y is equal to 1 over x minus 3. And again, we know how to look for transformations by looking for things like these. Y is equal to f of x plus c. This is a vertical transformation going upwards. Y is equal to some function x minus c. This is a vertical transformation downwards. Y is equal to f of x plus c. This is a horizontal transformation to the left. Y is equal to f of x minus c. This is a horizontal transformation to the right. So we look here and try to identify what our sort of original function would be. I mean, that's kind of like the terminology I like to look. What would the base function? How about that? What would the base function be for this equation? Base function would be y is equal to 1 over x. So if we take the base function to be y is equal to 1 over x, we're replacing f of x with f of x minus 3. So if this was, instead of writing it in y form, let's say we wrote it in function notation. So so f of x, it's like we said f of x is equal to 1 over x, and then we said f of x is equal to x minus 3, and that is equal to 1 over x minus 3. So that's kind of the approach to thinking about these, I guess, if you want to try to understand them. But anyways, we can see that we're replacing the function with x minus some constant. So that means we're going to have a shift to the right, and a shift to the right by c units. All of these are by c units. So we're shifting over to the right by 3 units. So we're going right 3. So let's put this on a graph now. And let's first draw the original, or the base function. So the base function y is equal to 1 over x, or f of x is equal to 1 over x, however you want to write it, looks like this. So it comes down from positive infinity and then goes to positive infinity all along the x-axis, and the same thing but negatively over here. And there is this value 0 that it approaches but never touches. So this is 0. So if we wanted to shift this 3 units to the right, we sort of just take the center of this graph and move it 1, 2, 3 units over. So instead of 0 being the number that this graph approaches and never touches, it's going to be positive 3. So let's say, so this would be where 0 is on that graph, and it would look like this. And I'm just going to sketch this. I'm not going to plot points. So it would look a lot like this. And this is 3. This is x is equal to 3 right here. And that's the only thing that's happening here. We're only having a vertical or a horizontal shift of 3 units to the right. And that's all that's happening. That's the only transformation for this function. Let's look at 2 more. Let's say in this example I have y is equal to the cube root of x plus 1. And I want to know what transformations are taking place. So let's try to find the base function first. That's the best way to start when approaching these problems. So we know one of the functions from our library functions is y is equal to the cube root of x. So this would be a good base function to use. So this is a good base function to use. And if this is our base function, then we're adding 1 to it. So we're having a constant added to the f of x. So that's going to be very much like y is equal to f of x plus c, which means we have a vertical shift up one unit in this case, by c units, and we go over to c and we see c is 1. So we say there's an upshift of 1. So let's graph this. Y is equal to the cube root of x, or f of x is equal to the cube root of x. Looks like this. And again, this is sort of a sketch. I'm not putting points on, so it may not be completely precise. And now we're going to shift vertically. Y is equal to the cube root of x plus 1, or f of x is equal to the cube root of x plus 1. So we're taking this graph and then moving it up 1 unit. So taking this entire graph and then just moving it up 1. So this center would be right here. So we'll start at 0, 1, and then we just make the same shape. So like this. And this is all that's taken place. We've just gone up by 1 unit. But that's not always going to be the case. There can be a horizontal shift and a vertical shift, and that's what I'm going to do in this final example. And also, once we learn about reflections across the y-axis, there are many other things that can happen to a function. There can be compression, there can be expansion, but for right now all we're doing is vertical and horizontal shifts. But let's do one where 2 things happen at once. Let's say I have x minus 2 squared plus 1. So if I want to pick a base function, or let me put the y is equal, So if I want to pick a base function, a good base, we have a squared. If this 2 wasn't here, it'd be x squared, and this is another constant. So a good base to pick is y is equal to x squared, or f of x is equal to x squared. However you want to write it out. But in this case, we have a constant being added to it. We have some constant being added to it, and we also have some constant being subtracted from the x. So if we go over here, we have 2 things happening. We're having a vertical shift of 1. We're having a vertical shift of up 1 from this, and we're shifting to the right 2 units. To the right 2. So here in this example, we have both happening at once, and that's perfectly fine. That can definitely happen. So let's now graph this out. So let's first graph out our base function. You don't have to graph out the base function if you don't want to. I'm just doing it in this example so it's clear to show what's happening to the graph. So we have y is equal to x squared, or f of x is equal to x squared. And we've seen this plenty of times. We have a center at 0, 0, and it goes up like this, and it's symmetrical to the y-axis, just like that. So now if we wanted to transform this function, So now we have y is equal to x minus 2 squared plus 1, or f of x is equal to x minus 2 squared plus 1. So now we're having this graph shifted to the right 2 units and up 1 unit. So let's do that. Let's start by shifting this point. All the points of this graph are going to be shifted to the right 2 and up 1. So let's start with this vertex. So it's at 0, 0. We're going to shift it to the right 2 and then up 1. And then if we took the trouble to find the individual points, we would just add, if we had a table, let's say we had a table of all of its x values. It's x, y, it's x, it's y, x, y. What we're doing is just, to all of these points, we're adding, let's think about it like this. If we had a set of ordered pairs, x, y, so we found a bunch of different ordered pairs for it. By using the table, we found a bunch of ordered pairs. Basically what we're going to be doing is just adding 2 and 1 to each point. So now let's go and graph. So we've added 2 and 1 to each one, and that's going to have a shape like this. Again, I haven't taken the trouble to make a table and do all that. This is really just to show an example of how you would this is really about being able just to look and identify them. But it definitely take the time to understand what's going on. It'll definitely be very, very useful in the future. So this point is 2, 1. And over here it's at 0, 0.